So let's take a closer look at the what's called a variable scope, and that means when is a variable valid and when is it invalid and so forth, and including global variables. So here I have a very short program with a main and a function called display value. In main I define a variable called number and I output what that value is in main. Alright, and then there's a function called display value, which also tries to output the value of number. But you can see here it has a red squiggly line underneath it. To try to compile, it'll give me a compile error saying it doesn't know what number is inside display value, because this variable is local to main, and it's only valid from this point where I declare it to the end of main. Nowhere else. This function is not part of main. This display value is not part of main. Even if I was to call the function here, which I can right here, right, the function itself is not part of main. The call to it is part of main, but the actual code is not. So that's why number is unknown here. Alright, so let's create a local variable inside this procedure, and we'll set that equal to 10, and let's set this guy to a value up here of, let's say, 20. Alright, now all the squiggly lines are gone. If it compiles, it should run, which we'll do, and you should see two outputs. First saying that variable in main, and we should see it 20. Whoops, what do I have wrong here? Identifier. Oh, need my prototype for my function. There we go. Alright, so we should see that it outputs at main, the value is 20, and then we should see in display value that the value is going to be 10, and here's that output. Alright, exactly as we've seen. Now those two variables are local variables to their functions. This number is local to the main, this number is local to the display value. Even though they have the same name, they are completely two different variables in the program. Alright, when C++ goes ahead and compiles this, it gives this number a slightly different name, so it knows that it's part of display value, and it gives this one a different name because it knows it's part of main. Alright, so it does some changing of the variables and function names in the background, which we'll never see and don't care about really. Alright, but the idea is the scope. So this one's declared here, it's valid all the way through up to this curly bracket. Same thing with this number, it's valid from this point forward to the first closing curly bracket. Alright, so let's play around. We can make this a parameter, right, which we talked about before. If you make number a parameter instead of a local variable, it really is a local variable still. So the only difference is it allows a value to be passed to the procedure. Alright, so let's go one more step, and we're going to take this now and place it up in here, which now makes that a global variable, which means it's visible throughout the entire file from this point forward. From when it's declared forward, it's valid to the entire file. Alright, but we're not going to see any change in the results, as you'll see here, is because we still have this one here that's local, meaning okay, this will override any other variable called number and use that version only. Right, so you see we still get the 20 and the 10. Alright, so this one's global, it's good throughout the entire file, but I declared another one here, so this one overrides that one from just within here. Right, otherwise numbers this one everywhere else. Right, so this is just local, so local will use that one. If we comment this out, now that function's going to use the global variable. Alright, so we should see the 20 now as output 2 times, and that's what we see now. Alright, and that may seem good and very easy to program. You don't have to worry about parameters or anything else like that, but it is an extremely bad programming practice. Alright, we try to hide or protect the data as best as we can. Global variables make that a very hard thing to do, meaning that this variable can be changed at any time. Even though this is a display value function, meaning it's only going to do output, I could change the value here. I can still say number equals 10, right? Not thinking that it's a global variable. Now I change how everybody else uses this number in the program, and you can see here in the output we're back to the 20 and the 10 values. Alright, doing that also, I'm going to add another cout statement here. Alright, and we're back in main again, and you can see that the result of changing this number to a 10 here affects the rest of the program, because we started with the 20, we went into the display value, changed it to a 10, displayed the 10, went back to main, and it's still a 10. Alright, so you should always avoid doing this. There is no reason to do global variables. Alright, it's a bad thing, so you should never use them. Alright, it's a very bad programming practice. Alright, always get around them. The only type of variables that should be up here are constant variables. Alright, now this means this value can never change. The number is always going to be 20, and you can see down in here the number is now an invalid statement trying to assign it to a 20. It's global, it's constant, it's something we never want to change, so it's protected, so it's a good thing to use. Right? And then you don't have to pass the constants around to functions all the time. Right? You just declare all your constants up above main, right below your prototypes, function prototypes. Right? So that's variable scope. We'll come back to this concept later on when we introduce more things, but I definitely want to stress the use of global variables is not good, and we should avoid those. Right? It's just common practice in the field.